All right, so we are going to work on some sample problems during this swing day. The first thing that we're going to do is go over our 3 different types of notations, the 3 different ways to represent electron configurations. The first element we're going to look at is fluorine, and we're going to do the electron configuration notation. We're going to do the noble gas configuration and the orbital diagram for fluorine. Okay? Definitely want to follow along with me so that you can have this as reference if you need to study at some point in the future. Now you want to have a periodic table present. Okay, we're talking about fluorine, which is F over here, number 9. So the reason I wanted to check the periodic table is so I can see that it is in fact number 9. That lets me know that there are 9 protons, and if this is an electrically balanced atom, it's going to have 9 electrons. Now I know how many electrons I need to account for. Now we can start filling some configurations here. So electron configuration for fluorine, okay, which has 9 electrons. I know that now. I'm going to fill the 1s first, then the 2s, then the 2p. Now I can fill 2 electrons into the 1s. I can fill 2 electrons in the 2s. That's a total of 4, so I need to account for 5 more. How many electrons can a p orbital hold? 6. There are 3 suborbitals. That's true, Johnny, but if each suborbital can hold 2 electrons, that's a total of 6 electrons. I need to account for 5 more, so yes, they're all going to fit into that 2p orbital. Now onto the noble gas notation. I need to find my periodic table yet again. Here's fluorine. Now I'm going to go backwards until I find the very first noble gas that I come to. In this case, it's actually going to be helium. So I'm going to go backwards to helium. So I'm going to write helium in brackets. And what that does is it represents all the inner shell electrons. Now, for this particular example, it's not going to help me that much because all I don't have to write now is 1s2. Because in the outer shell, I still have 2s2 and 2p5. But that's the noble gas configuration for fluorine. Now I'm going to go into the orbital notation. I have 3 different orbitals. I have a 1s orbital. I have a 2s orbital, and I have a 2p orbital. There's 1 suborbital in each of my s's, and then there are 3 suborbital in the p. I'm going to fill 2 electrons into my 1s, each with opposite spin, 2 electrons in my 2s, each with opposite spin. Then I'm going to fill 5 into this 2p. I know that because I already wrote it down twice. So I'm going to fill each suborbital singly first. Each electron having the same spin. That's 3 electrons. I need 2 more in this orbital. So 1, 2, opposite spin. Boom, I am done. I've done all 3 representations of fluorine. I am so good at this.